So I got these cheap push buttons off of eBay, and I got them for a project. They're supposed to be mounted on a front panel, as you can see the nut here. Um, Basically, they're cheap push buttons. What you do is when you press them, they are latched for the period you're pressing them, and then they dislodge. Um I want to talk about these because these buttons are horrible. Well, they're not horrible in that they're constructed horribly. They're horrible in that they bounce a lot. Now, for those of you who don't know what bouncing is basically when let me get a paper here. Bouncing is basically when you're expecting the button to be something like when you've got it closed, like when you have it open, like when the button is open, when you don't have it pressed, obviously. You expect the signal to be low or unlatched or whatever you want it to be. And when you press the button, when you latch the button, anyway, I'm bad at drawing. It should go high like this, and then it goes low once again as soon as you release the button. It unlatches and it goes low again. What happens is something known as bouncing. What bouncing is that basically when you press the button, it doesn't immediately go up. Well, actually it does immediately go up, but then it bounces back down, and then it oscillates a few times here. Now this is over exaggerated, but there's usually a bit of bouncing. And not only that, when you press the button, this also happens when you release the button. So for example, when I release the button, it should just go low, but it doesn't. It bounces back. The reason for this, there's a couple of reasons, but the main reason for bouncing is construction. Now, construction means that the actual construction of the button. Some buttons have like spring-loaded mechanisms and gold-plated contact plates, the works, but the problem with those is obviously price. Now if I had bought a button for like $50, I would have expected it to not bounce at all, but these buttons I bought for $6, right? So I expect these to bounce bad, right? So let's move on. How do we test bouncing? So this is something that I made a while ago, and this is as I was saying, that I bought these buttons for a project, and this is basically the main control board for that project. Right now what I'm gonna do is, as you can see, there's 3 pin connectors here. They're left for the buttons, and I don't know if you can see that, but there's 3 pin connectors there, and they're left for the button. What I'm gonna do is I'm basically just gonna connect the button onto these, and I'm just gonna write a simple program to upload to this Arduino, which will basically read how many bounces I get off of each push of these buttons. So I'm just gonna go write that program, and I'll be back. In the Arduino environment, I'm just gonna make a quick program which will count the amount of times that the switch input changes over a period of 5 seconds. The program I'll link in the description. So you guys can't see the LCD, so I'm just gonna pick it up. So the program that I've made is basically counting the number of state changes. So when I press this button once, it causes 2 state changes, one for the high state when it's pressed, and then one for the release. So basically, if I press this button twice, this should count 4 state changes. Right, so now that when it goes back to, now I'm gonna press the button twice, 1, 2, and it counts 4 state changes. Right, that's perfect. So now what happens when I press the button more times, like say 6 times? In theory it should count 12, right? So Will it? 1, 2, 3, 4, 5, 6. 36. 36. God damn, these buttons are horrible. So how do you rectify this problem? Well, there's a couple of ways. The easiest way is probably this. A tiny little capacitor. This capacitor is 0.33 microfarads. Focus, please focus. Yeah, there you go. It's 0.33 microfarads. And what I'm going to do is basically connect this capacitor in parallel with this button. So it basically forms a low pass filter with the internal pull-up resistor of the Arduino. And if you don't understand that, don't worry about it. So now, as you can see, I've connected this capacitor, which basically shoved it into the heat shrink, not the sink, the heat shrink. And now if I press this button, I just go back to 1, 2, 3, 4, 5 times. It counts 10. That's perfect, ain't it? This is amazing, isn't it? To be honest, I didn't think it would work this well. Okay. So another popular method of debouncing is known as software debounce. Basically what we do is you introduce a little delay after each press. Like the first time the Arduino detects a state change, it will delay for a while. It'll basically skip any more bounces for a specific period of time. That period of time is usually 20 to 25 milliseconds, and that usually works fine to remove all bouncing. And we can test that out right now. You can see I've taken out the capacitor, and we can go back into the program, make a little edit. Adding a simple delay of about 25 milliseconds after every bounce is a crude way of doing debouncing. In reality, you'd be using a timer or timer interrupt, so it doesn't interfere with the rest of your program. But for proof of concept right now, this will do. And we'll press it 5 times again. Ooh, I think we caught it right between the last bounce. There you go. 10. Just like with the capacitor. 1, 2, 3, 4, 5. 10. So that's software debouncing. So you can use either hardware debouncing or software debouncing, and both seem to work fine. Now the only thing that it depends on is obviously your application. Sometimes you won't have program space or timers to implement software debouncing, so you can use hardware debouncing. Other times, well, most of the times, software debouncing works much better, or just as well at least, and you don't have to put extra resources into it. I hope this video proved useful to you. I might be making more in the future, I don't know, but if you found this useful, let me know in the comments.